Next up, in modular arithmetic, identity and inverse. So, in modular arithmetic, the only thing you need to know about identity and inverse is that when we say additive inverse, it's just a negative version of your value. We'll call it R. When we say multiplicative inverse, it is just R raised to a negative power. Why? Because what's the opposite of addition? Subtraction. And thus, there's a negative sign. What's the opposite of multiplication? Division. And when we describe this value, R raised to the negative 1, is just simply 1 over R. So, logically, you will be able to understand when the given states that they want an additive inverse, negative R, or a multiplicative inverse, R to the negative 1. So, how do we use this information to solve some identity and inverse problems? Simply put, let's have question number 1. The additive inverse of 9 mod 15. So we need to find the additive inverse of 9 mod 15. So we need to first convert this expression into a modular expression. So it says here additive inverse of 9, and we said here earlier that the additive inverse is just the negative value of what's speaking about. So it's just simply negative 9 congruent to y mod 15. Does this look familiar? From the last video, it follows the format from when we interpret this expression. Therefore, we can also apply the K formula in order to know the value that can make this expression, or the y expression, or the y value that can make this expression valid. Remember, the only way that the value of y can make this expression valid is if, when applied to this formula with their variables, the result of k would be a whole number. Therefore, let us try and apply. So x will be negative 9, y is just y, and mod 15 is n. So we need to find values of y that will make k a whole number. So of course, I already made a table. So we have y, 2, 3, 4, 5, 6, 7 consecutive numbers, and k, when we input y, these are the results. Negative 11 over 5, negative 4 fifths, negative 13 15, negative 14 over 15, negative 1, and negative 16 over 15. The only value of y that can make k a whole number is 6, because negative 1. Regardless if it's positive or negative, as long as it's a whole number, k, then that value of y is the one that can make that expression valid. So, using that logic, we know that y, the only value of y that can make this expression whole number is 6. Therefore, the additive inverse of 9 mod 15, since we have a value of y, is negative 9 congruent to 6 mod 15. And that is the answer. That's just simply the answer of this question. Next, the multiplicative inverse of 4 mod 12. Still the same logic, same process. The multiplicative inverse, instead of negative r, will go to r to the negative 1. So, it's just simply put, multiplicative inverse of 4 to the negative 1, mod 12, put mod 12 here, and we have an unknown variable which is y. So same, follow the K formula, apply your variables, 1/4 minus y over 12, and find the values of y that can make this expression into a whole number. Therefore, we use a table, and as you can see, even if I continue infinitely, even on the left side, I did it on paper, but my whiteboard is not big enough to show all my solutions. So I just, for coherence sake, I did all possible variables of y, or values of y, and I cannot find a value of y that can make k into a whole number. And that happens. It's okay. Therefore, we can conclude that there is no y value that can satisfy this equation, or the multiplicative inverse of 4 mod 12 does not exist. And that is an answer. That's also a valid answer.